Hey everyone, today we are going to solve the daily LeetCode challenge of 2nd March 2024, and the problem statement is squares of a sorted array. So let us first understand the problem statement. So according to the problem, we have been given an integer array nums such that it contains both positive as well as negative integers. Okay, and what we have to return is we have to give an array that contains squares of each element in sorted order. Okay. Additionally, this nums is also sorted. You can see that we have -5, then -1, 0, 3, 4. So this is also in sorted order, right? So what would be the answer for this nums? We will have answer as 0, 1, 9, 16, and 25. So you can see that this is the square of this 0, then we have the square of 1, then we have the square of 3, then we have the square of 4, and then we have the square of -5. And this is in sorted order. Okay. Now the question is, how are we going to solve this problem? So we will be discussing two approaches. So let us first discuss the approach 1. So what we'll be doing in approach 1 is we will iterate over this nums array, and what we'll do is at each index we will store the square of that particular value. Okay, and then we will sort it. So what do I mean by this? Say for example, this is our nums. Okay, this is -5, this is -1, this is 0, this is 3, this is 4. So what we'll do is we are present at -5, so we'll replace this -5 with its square. So it would become 25. Then we'll move forward. We'll replace this -1 with its square. So it will become 1. Then we'll move forward. Now we are at 0. We'll replace it with its square. It will become 0. Then we'll move forward. We are having 3. We'll replace it with its square. It will become 9. Then we'll move forward. We have 4. We'll replace it with its square. It will become 16. Again, we'll move forward. Now we can see that we don't have any more elements. So it means that we have found out the square of each of the element of nums. Now what we have to do is, according to the question, what we were supposed to do, we were supposed to first find the square and then we were supposed to sort it. So now that we have found out the square, what we'll do is we'll simply sort this. So what we'll get 0, 1, 9, 16, and 25. Correct? So this is our answer. So this would be nums only, right? So what we were doing, we were first find square of each element, and after that what we were doing, we were sorting nums, right? So for doing this, the time complexity would be order of n log n. Why n log n? So you can see that first what we are doing, first we are finding out the square of each of the element, right? So for this process, we are going to take a time complexity of order of n, right? Because we will be iterating over each of the element. After that, what we are doing, we are sorting nums. So for sorting nums, what would be the time complexity? It would be nothing but order of n log n. Fine. That's the reason why our time complexity is order of n log n. And talking about the space complexity, it would be order of log n. Why order of log n? Because in case of C++, when we will use the sort function, it internally takes a space complexity of log n. So if you are using Python or Java, so according to programming language, the space complexity will differ in that case. Okay. So this was the first approach. So here you can see that the time complexity is order of n log n. So can we come with an approach that has a better time complexity, that is, which has a time complexity of order of n? So the answer is yes. So now let's discuss the second approach. Okay, so one thing you might have noticed that in nums we have both negative as well as positive integer, right? So let's see if we have -5 and 4. So it's clear that -5 is lesser than 4. But when we find out the square, so we'll get 25 and here it would be 16. So the square of -5 is greater than the square of 4. The reason being the square of any number is always positive, correct? And if we will see that if we ignore this negative sign and if we consider only the absolute value, right? So here what we have, it's 5 and here what we have, it's 4. So 5 is greater than 4. That's so it's obvious that the square of 5 will always be greater than the square of 4, correct? So what we will do in the second approach is we will take two pointers. Say this is start and this is end. And what we will do, we will compare the absolute value present at these pointers. That is, we'll compare with 5 and 4, not with -5. The reason being, if we'll compare -5 and 4, then we'll always get that -5 is lesser than 4. But when we'll find out the square, in that case, the square of -5 will be greater, right? So that's the reason we'll be comparing the absolute value. Initially, we'll start on by taking a vector, let's say answer, and its size would be same as the size of the given vector. Okay, so here the size is 5, so it's the size of answer will also be 5. Now what we will do, we will run a for loop from 4 to 0. Why from 4 to 0? Because we will first start populating the last index of answer. Why? Because we want to populate the max value first, and then as we'll move towards the left, we'll be populating the value which is comparatively lesser than this particular value. Okay, so now what we'll do, we will check that the value present at start pointer is greater than the value present at end pointer. So if we will take the absolute value, what we'll have? We will have 5. So initially, let's say this is I. So initially our I will be 4. So now our start is at this 0th index. So we will have 5 and we'll have 4. Why? Because we are comparing the absolute value. So 5 is greater than 4, right? That is, the value at start is greater than the value at end. What we will do? We will place the square of this 5 at this particular index. So we'll have 25. And since the value at start is greater, so what we'll do? We will increment start. So our start pointer will come here. Okay. Now what will happen? Our I will get decremented to 3. So this pointer is now here. Now we'll check that the absolute value is of -1 is 1. And our end is at 4. So here 4 is greater than 1, right? That is, the value at end is greater than the value present at start. So what we'll do? Here we will place the square of 4, which is 16. Okay. And since the value present at end was greater, what we'll do? We will decrement end. So we'll have end over here. Now we'll compare 1 and 3. Okay. So 3 is greater than 1, which means that the value present at end is greater than the value present at start. Correct. Now what we will do? By this time, our I would become 2 and this pointer is over here. That is, I is over here. And what we'll do? We will place the square of 3 because 3 is greater, right? So it would be 9 over here. So since the value at end was greater, now we'll decrement end. So we'll have end over here and our I will get decremented to 1. So now our I pointer is over here. Now we'll check 1 and 0. So 1 is greater than 0. So what we'll do? Here we'll place the square of 1. So it would be 1. And since the value at start was greater, so what we'll do? We will increment start. So now start and end both are at 0th index. So now we'll check that is 0 greater than 0 or is 0 lesser than 0. So what we'll do? Over here, by this time our I pointer would become 0 and over here we will place 0. And this is the answer that we have. You can see that we have 0, 1, 9, 16, 25. So 0, it's the square of this. 1, it's the square of this. 9, it's the square of 3. 16 is the square of 4 and 25, it's the square of -5. And this is our answer. So now let's quickly code this. First of all, we'll initialize an answer vector and it will have a size of nums.size. So here it would be of size n. Let's take 2 pointers, start and end. Start would be initially 0 and end would be initially n minus 1, that is nums.size -1. And then we'll have a loop which will start. Here you can see that this loop was starting from the nums.size to 0th index. So it would be n minus 1, index greater than equal to 0, index of minus minus. And what we will check? We'll check the absolute value, right? Here what we were doing, we were checking the absolute value. So we'll check if absolute value of nums of start is greater than absolute value of nums of end. In that case, what we will do? In that case, we'll set answer of index as nums of start into nums of start. Correct? Why? Because the absolute value of start is greater, right? So obviously its square would be greater than the square of nums of end. So that's the reason why we are populating answer of index as the square of nums of start. And since the value at start was greater, so we'll increment the start pointer. Otherwise, what we'll do? Otherwise, what does it mean? Otherwise, the absolute value of nums of end is greater. So what we'll do? We'll set answer of index as the square of nums of index. And since the value present at end was greater, so what we will do? We will simply decrement the end pointer. And at the end, what we'll do? We'll return answer. So now let's run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So the time complexity is order of n. Why? Because here you can see that we are iterating over the complete answer array which has a size of n to populate it, right? So here we are using a time complexity of order of n, and the space complexity is also order of n. Why? Because here we have taken an additional vector answer whose size is n, correct? So that's all about today's daily LeetCode challenge. Thank you.